1 minute, it's a self-driving miniature car with a top speed of 14 miles per hour and a payload capacity of 110 pounds. The next, it's a two-legged humanoid robot able to climb staircases and use elevators. Its origins can be traced back to the animal, a quadrupedal robot that can autonomously navigate rough terrain. But the latest iteration, being developed by Zurich's Swiss Smile company, could eventually be more than just the most efficient delivery bot on the market. It could actually save lives. The Swiss Smile robot is the brainchild of Marko Bielonic.
I asked the question, can we improve the capabilities of these machines by 100-fold and not just through a marginal fraction? So the answer to this question was to add wheels, which managed to increase both speed and efficiency by these high fractions. And actually this humanoid robot was something that started out of fun. We said, shouldn't it be possible to stand on two legs and then drive around? And then we thought, okay, this could actually be something more than just a fun project.
The all-electric 6-foot-tall robot utilizes a combination of 16 motors, GPS, LiDAR sensors, and cameras to autonomously navigate city streets and avoid obstacles.
So the size is very much governed by the environments that we build for humans. And especially for the logistics part, you need to be able to carry a certain payload, otherwise you're not very useful. And then we have the whole aspect of becoming also environmental friendlier.
Some might wonder how the agile robot moves without any kinks when it switches from 4 wheels to 2 or climbs a staircase. This type of locomotion is taught to its AI control system with a reinforcement learning algorithm that utilizes a reward system to get what they want from the robot.
You have a robot and it does a motion. We evaluate this motion and we either punish the robot or give it a reward. And through this punishment and giving a reward, the robot tried to optimize for rewards. So one of the rewards could be don't fall, or one of the rewards are go over these stairs. 4,000 robots in parallel on a GPU accelerated computer, which is just a super beefy PC, generate maybe data of 1.5 years. And what the robot does, it has many different instances, and you refer to, for example, the stairs. So there's also a model of the stairs in that simulation environment where the robot tries to go down the stairs without falling.
Besides being an ideal tool for last-mile delivery services and a convenient data mapping option for creating digital twins of different environments, perhaps the most exciting potential future for the Swiss Smile robot is on rescue teams.
You want to send the robot into an unknown environment to make a first assessment for the rescue team so that they can go into a known environment. For finding lost people in forests, or let's say there's a fire that comes out on a chemical plant. I think if I make a naive prediction, I think it will happen before 2030. And for many years, we already work here in Switzerland with search and rescue teams directly to really see what is needed to actually make our robots useful for them. I think on one side is reasoning through intelligence for specific tasks, so that the robot, even without human guidance, can make important decisions. The next aspect will be fleets of robots. If you want to search a person in a forest, you don't want to send in one robot. You would like to send maybe 100 robots in.
2030 is still a ways away, but it's not hard to get excited imagining a rescue team of 100 transformer robots. But is it possible for them to do more than assist in rescue?
I don't want to take too much away because this will come, but we will be able to carry a person, and by staying at the same size.